In this example, we're going to continue from the previous example, so we're going to use the same data set and we're going to build a different feedforward neural network in Keras. And we're going to see how we can overcome some of the problems that occur when evaluating neural networks with the built-in functions in Keras. So let's define a new model. This is also going to be a sequential model. And now we're just going to have 2 layers. Right. We're just going to have 2 layers here. We want to have one dense layer, or we're going to have one hidden layer and one input and output layer. So we're going to have one dense layer. Let's put 90 units in it and use an rail activation. And again, we just have to specify the input shape, which is the shape of X for the second argument. Right, so we want this dense layer, and then we want to have an output layer, which is also going to be dense, with 6 units and a softmax activation function. Right, so as we saw earlier, the softmax activation function will determine which output predicts the highest probability. So this is our model, and then we want to compile it. We're going to use the same optimizer and learning rate. Right, we set the learning rate. We next define the loss. So we have categorical cross entropy. We're using the same thing. And then we want to use the same matrix. So now we're not going to use the accuracy, since we saw it doesn't really work that well for this type of problem. We're just going to use the categorical accuracy. We're still going to use the precision and the recall. Alright, so we're going to compile our network this way. Then we're going to train it. So I want to train it on X and encoded version of Y. That was Y henk. And we want to specify the number of epochs. Let's make it 500 again. And let's make this verbose. So we run this now. And we see that for this network we start with a much lower loss and a much higher accuracy from the start. And as we train further, we see that we don't really get any improvement. We get to 99% training accuracy. So here maybe we need fewer epochs to train. But we can see that this network that we just built is much more suited to the problem that we have than the previous one. So let's just wait for this training to finish. So one problem that can occur in cases like this is that we get overfitting. That is, that the network fits the training set really well, but it doesn't generalize well, so it doesn't perform as well for the test set. We'll see whether that's the case here once this finishes training. So the training is slower here, but we don't need the 500 epochs. We could maybe set this to even 10 epochs would be enough, or maybe 20. Right, so this has finished training. In the end, we have some very high accuracy, precision, and recall for the training set. Let's see how this performs for the test set. So we want to evaluate this on X test and Y test encoded. So let's see, we got a very high accuracy for this. So for the test set as well. So we didn't overfit here. We see that the accuracy is still very high. The accuracy, precision, and recall are all very high even for the test set. So let's see what the predictions look like here. I want to predict X test and Y test encoded. No, we just need X test here. Sorry, so we'll just do this and let's see what this looks like. Alright, so here we can see that we already have some cases where the value of the predicted class or the probability of the class that has the highest probability is 1. That happens here for the first sample and the second and the third. And then here we have 9.999 accuracy, so or 99.9999 accuracy, which can round up to 1. Then we have again a probability of 1% for the correct class for this sample and for this one as well. So in this case we would actually get a higher value for the accuracy metric, but it's still not suitable for this type of problem. For this type of problem, so multi-class classification, we need to use categorical accuracy. So the last thing that we want to see is how we can predict, maybe view the accuracy that we get using this in a simpler way. And especially overcome the problem of not having an F1 score and having to use it from a different library. So we're still going to look at this. We're going to create another YPred class. So this is gonna tell us what's the index of the predicted class. For this new set of predictions. And let's take a look at it. And we already have the this version of the test set, so we can just reuse it from the previous example. So we can see what this looks like. And then one thing that we can use is the classification report that scikit-learn has. So from scikit-learn metrics, we want to import classification report. Now let's run this classification report and see what it looks like. So we see the classification report and we want to pass in the correct labels first. So that's a Y test class for us. And then we want to pass in the predicted labels. And let's see what this looks like. So what we get here is the result for each. First, we look at. We see that we have multiple values for the precision, recall, and F1 score. So that's because we have a multi-class classification problem here. So we compute the precision, recall, and F1 score for each class. So class 0, that was laying. We have 537 samples, and we see how well this was classified. So we can look at the values for precision, recall, and F1 score, and then here we get the macro and weighted average, which is how we compute the precision, recall, and F1 score for multi-class classification problems. And additionally, here we can see the accuracy of the classification. So the accuracy is this categorical accuracy that we had here, that Keras computed. Only this is rounded. This is just rounded. Another note about the evaluations here computed by Keras is that Keras computes these values batch-wise. So the values for the loss, categorical accuracy, precision, and recall that we have here are actually only the values for the last batch, and they often are representative of the performance on the entire data set. However, it's still not. This is still computed only for the last. The thing that we see here was only computed for the last batch. However, if we compare these values to the ones that we get here, we see that they are very similar. Only in scikit-learn we're round here to 2 decimals.